here's my app. And here's my app again. And here is my app again. In many cases, adding one more screen to an existing Qt-based product is not trivial. Meanwhile, users like me walk around with smartphones, laptops and tablets. I will show you how to stream your Qt app on any device that can show a web page. This technology demo showcases how to extend an existing Qt application with WebRTC Streaming, so that the app can be accessed from anywhere in the form of a web view inside a browser. So basically, this works like a live stream on YouTube. But the content is your app. And it gets even better. We use the GStreamer library to efficiently capture the Qt window and encode it into a video stream. This is good because we do not move the content from GPU to CPU multiple times, but instead encode it into a video right where it was created initially on the GPU. This already compresses the video down to a manageable size. GStreamer then handles the management for the WebRTC video streams, supplying as many external viewers as is required for the project. WebRTC manages all ongoing streams so that, for instance, viewers who joined streaming but did not yet start the video do not unnecessarily receive the data. Also, the encoding format can be negotiated between the app and the viewer's hardware to save bandwidth and to use optimal codec fitting phones and tablets. Here comes the cherry on top. Interaction is possible as well, not just viewing. To understand this, I give you some background. For the use case of digital whiteboards in WebRTC, WebRTC always contained an interaction channel back from the viewers to the sender of a video stream. This has been a part of WebRTC for at least 10 years. At KDAB, we made use of this existing backchannel to send button presses, keyboard input and touch gestures from the web browsers back to the streamed Qt app. Therefore, we recently improved GStreamer with some patches to implement this kind of interaction. This means user can operate the Qt application from inside their browsers if wanted. Still, all viewers operate the same app. So, how could you add this to your app easily? First, let's look at what I added to my app's main function. As you can see, we are taking out the quick window here from the engine to use it later to be filmed for our web streaming. Then we also make a new variable called WebRootPath, which basically provides the web page to the streaming pipeline. In line 52 here, you see the streaming pipeline itself. This is the most important part. This is what sends the video to your users. So let's look inside. When we look into the implementation of streaming pipeline, we will see that the most important part is building this pipeline. This pipeline consists of multiple elements which are chained with this exclamation mark here. We have the QML6 GL source, which we name source, which basically films the window. We then need to flip the video because all video is turned around in the GPU, and then download the GL. This sounds like putting it to the CPU, but it's not. It's staying on the GPU. We then convert the video, which happens in the GPU's video converter or encoder, and then use the WebRTC sync, which finally sends it out to the browsers of our users to be shown in a video. We give these WebRTC sync the name sync. As you can see a bit further down, we will have properties set to source and sync. There might be the window property, which is the window that needs to be filmed, or on the sync, there might be the web server directory, which is the website that needs to be sent so the users can see the video in their browsers. You can download all of this code on GitHub in the KDAB TV GitHub repository. So how could this be used in the real world? The first scenario would be from no screen to screen. Just use your user's phone as the first screen. Imagine you already have a product line with screens, but you want to add another product variant without a screen. This is then a great option. The Headless, lightweight product could have a QR code printed on it, and users could use their phone as the first screen. There would be no need to develop a new UI if it already existed for the screen version of your product. I know of some producers of smart doorbells that could use exactly that. In a premium version, they sell a screen for inside the house, but the light version, a streamed interface on your phone, would be enough. So in this scenario, we would save money by replacing parts with already existing smartphones. Another way would be to get the screen closer to what's happening. Imagine a factory with a control room with many screens and a machine floor where the actual machines operate. A trained technician could simply clone the machine room app onto their phone and analyze and change parameters while performing maintenance on the machine floor. In this scenario, we save time because we do not have the technician running back and forth to the control room. In a third scenario, and if supervision is needed, a view-only copy of the application could be added quickly to provide a remote quality assurance worker with a safe but quick overview. Here, a classic example could be a production manager being able to see the output of a production line without being able to change parameters on the machines. Here, the bonus we get is offsite monitoring, increasing safety and controlling. Imagine scenario 4. A remote support technician could intervene and assist or guide users. So this is the classical support hotline scenario with screencast. Here, we save the travel of a more skilled expert to the device. In the last scenario, there might be a need to integrate multiple display outputs and views into a single app or a web page, which is also a challenge. For example, when the machines are far apart. Imagine a mining operation where all machines are very far apart or even moving. It's not easy to add cables for communication. Still, with this technology, all display outputs could be combined into one web view, featuring multiple videos in a grid. Here, to allow for mobile usage and overview without being in the way. Be aware that this technology solution does not include software security. You need to make sure to operate in a safe network in order to be sure your machines are protected. So in this video, I showed you how KDAB made Qt streaming simple and usable for many scenarios. Maybe one of the proposed solutions might be something for you. Check out the GitHub link and play with it. And if you need any services around this idea, reach out to us here at KDAB. This is it for today. Auf Wiedersehen and see you next time.